In this quick and short video, I just want to show you how you could compute these partial derivatives using technology. So I'm going to use Wolfram Alpha, and if you go to wolframalpha.com, it'll take you to this almost like Google looking browser. And if in here you type in the function, so I'm just going to go ahead and paste what I already have. And this is the function right here, 9.4 plus 7.8c plus 3.6c squared minus 38f minus 22c times f plus 43f squared. I've put that in parentheses, and then out front I put the notation ddc. Okay, that means the derivative of this entire thing with respect to c. So we're not going to define the m function, we're just going to say take the derivative of this expression. And then I put in the words at c comma f, that ordered pair, that input ordered pair equals, and then the value that I want it to evaluate at. When I press equals, we just want to check that the input interpretation is correct. So there you see the partial, we want to take the partial of this with respect to c, where c equals 0.7, f equals 0.7. That's exactly what we want. And we got a value of negative 2.56, which is exactly what we got when we computed it by hand. Now, if I just wanted the derivative function, I would just omit this right here, and this would give me the partial derivative of that function with respect to c. And now you can see we get 7.2c minus 22f plus 7.8, 7.c minus 22f plus 7.8. So that'll give us the derivative without plugging in values for us. Now, I'm going to put that back in there, and now we want to do the same thing. We want to take the derivative with respect to f. So I'll just change one thing. I'll make it ddf, and we should get 6.8, or 680%, which we indeed do. So it's less important to master, in my opinion, the act of taking derivatives, but much more important to be able to formulate a statement regarding what it means. Computers can do this stuff relatively easily and pretty much error-free. We just have to be good stewards of checking and making sure that the input interpretation, in other words, the computer's interpretation of what we typed in, is consistent with what we want. And that's really it. If our variables were x and y, then we could just do d slash dx. For instance, if I had the function x squared plus y squared plus 4 and I wanted the derivative of that, I would just say d slash dx. I like to put this in parentheses just to make sure that it takes the derivative of the entire thing. We should get 2x, which we do. If we take the derivative with respect to y, we should get 2y, which we do. And so that's how we take derivatives really quickly using Wolfram Alpha.